Hi there, I'm Rae Holcomb, a freshman physics and computer science student at Rice University. Today, we'll be answering the question of how likely we are to find life in outer space in the next decade. Let's talk science. In 1961, Dr. Frank Drake invented the Drake equation, which uses a bucket load of variables to predict how many intelligent alien civilizations there are in our Milky Way galaxy. We're going to modify his equation to estimate how likely we are to find extraterrestrial life in the next 10 years. The Drake equation starts by estimating how many planets are in our galaxy. But in our search for extraterrestrial life, we are not limited by the number of planets, but by how many we can discover. So how many exoplanets will we find in the next 10 years? Well, in the past 6 years, the Kepler space probe has confirmed over 1,000 exoplanets, which points to a rate of finding 100 to 200 per year. But with new missions like Minerva, the miniature exoplanet radial velocity array, opening this year, and TESS, the terrestrial exoplanet satellite survey, launching in 2017, we can expect to find hundreds more exoplanets every year. Let's estimate a rate of 500 per year for a total of 5,000 exoplanets. Next, we need to predict the fraction of planets that could potentially support life. According to the Planetary Habitability Laboratory, about 1 in every 100 planets we find now is Earth-like. However, Earth-like planets can take years to orbit their star. Since you need to see a planet orbit multiple times to confirm it exists, the longer we look, the more Earth-like planets we'll find. So let's set the habitability rate to 5%. The next variable is the likelihood that a habitable planet produces life. We have no data other than the Earth itself to predict this, so let's use a common value used in the Drake equation of around 20%. The Drake equation also considers the likelihood that life on a planet will evolve into intelligent life detectable from space. Drake meant transmitting signals like radio waves, but even non-intelligent life like bacteria leaves a detectable signature of oxygen, hydrocarbons, and reduced gases in the atmosphere. So let's set this parameter to 90%. The final variable in the Drake equation is the length of time that life on a planet remains detectable. Earth gives us a good model for this. Cyanobacteria have been pumping out oxygen on Earth for over 2.4 billion years, and will probably do so until the sun reaches the end of its lifespan in about 5 billion more years. So, 7 billion years of habitability divided by 10 billion years of existence gives us that a planet will sustain life for approximately 70% of its lifespan. Throw all those into the equation, and you get that we could discover a whopping 31.5 exoplanets crawling with microbes in the next decade. Extraterrestrial life might be a thing of the future, but just barely.